So we want to compute the integral of x cosine x from x equals 0 to x equals pi. And before we do any computation, we want to ask, is this integral, is the answer going to be positive? Is it going to be negative? Or is it going to be 0? And we want to ask that every time we're about to compute something. We want to think first, what do I expect for the answer? And then we're going to compute the value of the integral once we've thought about what we expect. So what's the sign of this integral going to be? If we were just integrating x, the sign would be positive since x is positive everywhere in the range. If we were just integrating cosine x, it would be 0. There's a positive part here and a negative part here, and they exactly balance. But we're using x to scale cosine x, and the negative part's getting really expanded, and the positive part is getting either shrunk or expanded a tiny bit. And so the positive part is overall probably getting smaller or staying the same. The negative part's getting a lot bigger, and so this guy's no longer, the product's no longer going to integrate to 0. The negative part's going to win, so the integral is going to be less than 0. Our first thought when we see the integral of x cosine x dx should be, I know how to integrate x, I know how to integrate cosine x, I don't know how to integrate their product. And when we need to integrate a product where we know how to integrate one of the component parts, our first thought should be integration by parts. The thing with integration by parts is I don't actually have the formula memorized. I have to rederive it from the product rule. So we're going to go ahead and do that. So there's the product rule. D by dx of a product is equal to the derivative of the first part times the second plus the first times the derivative of the second. And to get to a rule about integration, we need to integrate both sides. Okay, so I've added some integral signs, and we're going to use definite integrals so we don't need to worry about what happens to any constants. Although if you do this with indefinite integrals, you'll see the constants sort of work out. And how does this matter for our function? Well, first of all, let's simplify this. We know from the fundamental theorem of calculus that this expression on the left is just the original function from a to b. And so how are we going to use this? We're going to think of x cosine x. We're going to think of this function x cosine x as being either du dx v or being u dv dx. And how do we choose which way to think about it, since it could certainly be either? We think about whether it's going to simplify our lives. If we think of x as a derivative and then we integrate it, we're going to get x squared, and that's going to make the function more complicated if we put an x squared there. So instead, we're going to think about x as u, so that then when we take a derivative, we're going to get 1, and that's going to make things simpler. We're setting u to x, and we're setting dv to x to cosine x. And we're just going to plug into that formula that we got from the product rule. So we had uv, it's going to be from 0 to pi, is equal to the integral from 0 to pi of 1 times negative sine x dx plus the integral from 0 to pi of x cosine x dx. We want to isolate the x cosine x dx, so we're going to bring it to the other side. Okay, so we get the integral from 0 to pi of x cosine x dx is equal to u times v from 0 to pi. Note that when we plug in the 0, we're going to get a 0 from the x. When we plug in a pi, we're going to get a 0 from the sine x. So actually, this term goes to 0. And then over here, we need to integrate negative sine x from 0 to pi, and we certainly know how to do that. So let's see. That's the integral. These negative signs combine to become positive. And so that's going to be equal to cosine x. That's right, because sine has a positive slope at 0, and cosine is equal to 1 at 0, which is positive. Okay, so we want the positive, and it's going to be from 0 to pi. And so that's going to be equal to -1 minus 1, which is equal to -2. This is negative, as we expected. And so that's that. We used integration by parts, and we've figured out whether the integral was going to be positive, negative, or 0, and then we went ahead and solved.